Hello, this is Kuntal Chakraborty, Assistant Professor of Electrical Engineering Department, Greater Kolkata College of Engineering and Management, JIS Group. I'm just going to give a lecture on PSW, RAM memory organization, and SFRs of 8051 microcontroller. Basically, PSW is program status word by which we can get some status of the flags after the arithmetic operations, as well as I'm just going to discuss RAM memory. 8051 microcontroller has 128 byte of RAM. So I'm just going to discuss the memory or RAM memory organizations, and in 8051 microcontroller has some SFRs, means special functions registers. So first I'm just going to discuss the PSW, that is the program status word. This is basically a 8-bit register, and by which we can get some status of the results or of any kind of arithmetic operations, whether the result is 0, if carry is generated or not, whether there is any auxiliary carry or not, and whether the results has any parity, even parity or odd parity we are getting from the final result or not, and data is flowed after the operations or not. That can be also get that kind of status also. So, and here we have 2 bit, that is RS0 and RS1, by which we can select the different register banks of 8051 microcontroller, that I will discuss later. First is a carry flag. First is a parity flag, that is a PSW 0.0. There is a parity flag. Basically, this parity flag, when it is 1, means a odd number of 1 in the accumulator, that is a result stored in accumulator. So if the number of 1s in the results is there, so that will be set as 1. Otherwise, that will be as 0. That will set as 0. Now the overflow flag, there is a PSW 0.2, that is the overflow flag. So this PSW 0.2 is actually the overflow flag. This is used to detect the error in signed arithmetic operations, and this is similar to carry flag, but difference is only that carry flag is used for the unsigned operations. So if any results overflowed from D8 bit, D7 bit to D8 bit, so if 8-bit operations is happening by using 8051 microcontroller, so there will be some overflow and it will be set as 1. Otherwise, that will be equal to 0. And F0, that is PSW 0.5, there is basically a user defined bit. The user can use it. So this is not internally used for the 8051 microcontroller. User can set any flags, or user can select any flags for its any kind of any purpose. And auxiliary carry basically generated from D3 to D4 bit. Any kind of arithmetic operations, if addition is going on, so if carry is generated from D3 to D4, at that time the auxiliary carry, that will be set as 1, otherwise that will be equal to 0. Now from D7 bit, if the carry is generated, then the PSW 0.7 that will be set as 1, otherwise that will be equal to 0. And this kind of carry bit that can be set as reset by using software also. We can set the carry by using a software instruction, that is set BC. So if you write set BC, then the carry that will be set as 1. Similarly, we can clear the bit, that is the carry bit, by using the CLRC. So that is the instructions by which we can set the carry as well as reset the carry. And next one is a RS1 and RS0. By using these 2 bits, we can select the registers bank of 8051 microcontroller. In registers, 8051 microcontroller has 4 registers bank, and these are the bank 0, bank 1, bank 2, and bank 3 that can be selected by choosing 0, 0, 0, 1, 1, 0, and 1, 1 combinations. So that registers can be selected. And these flags are used to select the bank registers only. So these are the banks by which we can store some data by selecting it. So these are the PSW, means the program status word by which we can select, we can get some status of the flags as well as we can select the register bank also. So next I'm just going to discuss that is a RAM memory organization. In 8051 microcontroller has 128 bytes of RAM, where from 00 to 1F it basically divided into 4 part, and each bank has 8 byte of memory, means it has 8 registers R0 to R7 each, means for each bank has 8 registers from R0 to R7, and its address is different obviously. For bank 0 that is 00 to 07, for bank 1 that is 08 to 0F, and for bank 2 that is 10 to 17, and for bank 3 that is 18 to 1F. So these are the banks, and that banks can be selected by the PSW status bit, that is RS1 and RS0. By selecting RS0 and RS1 we can select the register bank 0, bank 1, bank 2, bank 3 that I already discussed in case of PSW. And here we have 20 to 22F, this 16 byte of memory that is used as a bit addressable RAM, means every bit that can be addressed by using any operations. So that bit can be used, any bit of this particular address, particular memory that can be addressed. So that's why this memory is called the bit addressable memory. And from 30 to 7F, this basically used as a scratch pad RAM or the general memory where we can store some data. So in registers bank, I already discussed 00H to 1FH, that is we have 8 general purpose registers for each bank, and we can select by using RS0 to RS1, and bit addressable RAM, that is 28 to 2FH. The 8051 supports a special features which allows access to bit variables, means we can select any particular bit. So basically by selecting 0 or 1, we can select a bit and we can set it as 1, or as well as we can reset it as 0, and that can be done by using these instructions, that is set B and clear. We can set the bit as using set B, and we can clear the bit by using this instruction, that is CLR. So now examples like ACTB 22H means the RAM memory locations, that is 22H bits that can be set, and as well as if you clear it, then the bit of 22H that will be also clear. So that is the example, and the bit addressable area of this RAM is just 16 bytes of the internal RAM located between from 20H to 2FH that I already discussed. And next is the general purpose RAM, that is 30H to 7FH, even if 80 bytes of this internal RAM memory are available for the general purpose data storage. So this is used for the, we can write any data, we can write the program here also. So that is the general purpose of scratch pad RAM. So these are the 3 parts. One is a register bank, and second one is a bit addressable RAM, and third one is a general purpose RAM. So users should take care while using the memory locations from 00 to FH, since these locations are also the default register space, stack space also. In here the register bank 1 is used as stack also. So, and that is bit addressable space, but it is good practice to use the general purpose memory 32 to 7FH, and the general purpose RAM can be accessed using direct as well as indirect addressing modes also. So these are the RAM memory organizations of 8051 microcontroller. Now I'm just going to discuss the special functions registers, SFRs. In 8051 microcontroller, there are certain registers which uses the RAM address from 80H to FFH, and they are meant for certain specific operations, and these registers are called the special functions registers. Some of these registers are also bit addressable also. So in SFRs, some of them are like IO related ports, like P0, P1, P2 and P3. And some of them are control operations like TCON, means timer control operations like TCON, serial communication operations like SCON, power control operations like PCON. This kind of registers, special functions registers we have, and these are the bit addressables also. and remaining are the auxiliary SFRs, and in the sense that they don't directly configure the 8051 microcontroller. So these are the special functions registers. I'm just going to discuss every special functions of registers. Here we have the accumulator, that is also a special functions registers, that is also a bit addressable, and we have the B register that is used for the arithmetic operations like multiplication, division also, and its address is 0F0, and this is also a bit addressable, every bit of this particular register that can be accessed. And PSW I already discussed, and this is also a special functions registers, and that address is 0D0, and that is also a bit addressable RAM, and that we can address a particular bit, we can set or reset a particular bit of this particular PSW register. And we have a stack pointer. This is not bit addressable, but this is a special purpose register. This is a 8-bit register on which the stack address of the RAM that is stored. So to point out the particular stack that the stack pointer register is used. Next is a DPTR. This is a data pointer 2 bytes. Basically, this is a 2-byte instruction. This is not bit addressable, but this is also a special functions register by which we can select a particular data that is stored into a address. And it has a two part, that is DPL and DPH. Its address is 82 and 83, and we have 4 ports, that is P0, P1 and P2 and P3, and each port has a special functions register, P0 for port 0, P1 for port 1, P2 for port 2, and P3 for port 3, and its addresses are 80, 90, 0A, 00, B0. And all these ports are the bit addressable. Every bit, every pin of this port that can be addressed, a particular bit can be addressed. So we can set or reset a particular bit of this port or particular pin of this port. So next is the IP, that is the interrupt priority control register. That is also a bit addressable register, that is 0B8. So this IP is basically useful to for the priority selection of the interrupts of the 8051 microcontroller. And IE, that is the interrupt enable control register, that is its address is 0A8. That is also a bit addressable register by which we can basically select a particular interrupt, means enable the interrupt as well as disable the interrupt. And we have a TMOD register, which is used basically for the timer counter mode control operations. Its address is 89, but this is not a bit addressable register. TCON register, that is a bit addressable register, that is also used for the timer control operations. And T2CON, that is also used for the timer control operations, and this is also bit addressable, and that is basically used for 8052, not for 8051 microcontroller, and its address is 0C8. And T80, TL0, these are basically the timer 01 register, and this is a 16-byte register. TH0, it has an address of 80C, and TL0, its address is 80A. And TH1, TL1, this is a timer 1 register, and basically it is divided into 2 parts. Higher part is its address is 8B, and lower part's address is 8B. And basically these are not the bit addressable registers. TH2 and TL2, this is used only for the 8052, and this is not used in 8051 microcontroller. And RCAP2H, that is a timer counter capture register, high byte, that is also used in 8052 only. And RCCAP2L, that is also a lower byte, that is also used for 8052 only, but it is not used in 8051 microcontroller. And we have a SCON registers, that is a serial, that is used for the serial communication, and that is also a bit addressable. And we have the SBUF register, where the serial communication after receiving the data and after transmission, before transmission, the data is stored here. So this is not a bit addressable by 8-bit data that can be stored. So now next one is the PCON register. This is a power control register. This is not a bit addressable RAM, and by which we can address, that is used as a register, special purpose registers also. So that's all. I already discussed SFRs and RAM memory organizations, and the PSW of 8051 microcontroller. Thank you.